So here in this video we'll start with the miscellaneous exercise question number 16. Okay, so here miscellaneous exercise under chapter 7 we are going to start with question number 16. It's integral over e power 3 log x into x power 4 plus 1 the whole power minus 1. So from now on we've been seeing properties like e power 3 into e power 3 log x. So how do you write e power 3 log x? You can write it as e power log x cube divided by x power 4 plus 1. Because it's a whole power minus 1, so you write it as divided by x power 4 plus 1 dx, which is equal to, so this can be written as what actually here, x cube. I can write it here, e power log x is nothing but x, so we write it as x cube divided by x power 4 plus 1. Now looking at this one here, you know how is that you will integrate it by the method of substitution. What's the method of substitution here? Put t is equal to x power 4 plus 1. So what will I get? Your dt by dx is equal to 4x cube you get here. So you will have dx is equal to dt divided by 4x cube. What is your I equal to? Integral of x cube divided by t into dt divided by 4x cube. So x cube and x cube it gets cancelled. You are left with 1 by 4 into integral of dt divided by 2. What is integral of dt divided by t here? It's nothing but log of mod t. So you have it as 1 by 4 log mod t plus a constant. Now substitute the value of t. What's the value of t? What do you get here? It's nothing but x power 4 plus 1. So you will get it as 1 by 4 log mod of x power 4 plus 1 plus a constant. The 19th question. It's integral of sine inverse of root x minus cos inverse of root x divided by sine inverse of root x plus cos inverse of root x dx. So in order to evaluate this integral, I will be making use of this identity which you studied under inverse trigonometric function. What was it? Your sine inverse of x plus cos inverse of x is equal to pi by 2. So with that I can say sine inverse of root x plus cos inverse of root x is equal to pi by 2 I can say here. So what happens to the denominator? It will be nothing but pi by 2. And how is that I can write my cos inverse of x as actually here? My cos inverse of x can be written as pi by 2 minus sine inverse of x. So here I can write it as sine inverse of root x. Cos inverse of root x equal to pi by 2 minus sine inverse of root x. So it is integral of sine inverse of root x minus of pi by 2 minus sine inverse of root x divided by pi by 2 dx. Now what will happen here actually here? This pi by 2 when it goes to the numerator it will be nothing but 2 by pi. So I'll write it as 2 by pi integral of, here if you see it's minus pi by 2, minus of minus will give me plus. So it is plus sine inverse of root x plus sine inverse of root x. What will you get? It's 2 into sine inverse of root x dx. Okay. So we'll just integrate it here. So what will happen here actually? This of course it gets cancelled. You will be left with minus integral of dx plus 2 into 2 is what? 4 by 5 integral of sine inverse of root x dx. So this is equal to minus x plus 4 by pi. I1 is what you have here. Now to evaluate this integral, I1 is equal to integral of sine inverse of root x dx is what you have here. Okay. So how do I evaluate it? By the method of substitution. So what's the substitution? My problem is with this actually here. So I'll just write root x is equal to t. So what will I get? X is equal to t squared. So what is your dx equal to? It's nothing but 2t dt is what you have here. So when I substitute it, it's sine inverse of 2t dt which is equal to 2 into integral of t into sine inverse of t dt. So here what is the method? I'll have to integrate it by parts actually here. So when I take it by parts, this is your first one and this is the second one you get here. 2 into, what will I get? Sine inverse of t into integration of the second one, that is t dt, minus integral of differentiation of the first one, d by dt of sine inverse of t into integral of the second one, t dt, the whole dt. So you will have it as 2 into sine inverse of t. When I integrate this, you will get it as t squared by 2 minus integral of, what is differentiation of sine inverse of t? It's nothing but 1 by square root of 1 minus t squared into integral of t. What will I get? It's t squared by 2 dt. So here when I multiply this 2 and 2 gets cancelled. You're left with t squared into sine inverse of t is what you get here. Now take this minus sign inside. You write it as plus. Here again it's minus t squared by root of 1 minus t squared. Of course this 2 and 2 it gets cancelled here. Okay. Now when you have such an integrand, what did I tell you actually here? Bring the numerator also to the denominator. Bring the numerator as in the case of a denominator. So t squared sine inverse of t plus integral of, I will add and subtract 1 here. So it's 1 minus t squared minus 1 divided by root of 1 minus t squared dt. So after this I can just separate it as two separate integrands here and then integrate it with respect to t. So here you have it as t squared sine inverse of t plus integral of 1 minus t squared by root of 1 minus t squared dt minus integral of 1 by root of 1 minus t squared dt. So here it is equal to t squared into sine inverse of t plus when I rationalize it, it gets cancelled and you will be left with root of 1 minus t squared dt minus integral of 1 by root of 1 minus t squared dt. So what formula we'll be seeing here actually here? It's nothing but the formula which we saw under exercise 7.7, square root of integral of square root of a squared minus x squared. What's the formula you get here? It's x by 2 into square root of a squared minus x squared plus a squared by 2 into what will I get? Sine inverse of x by a. This is the formula you have here, okay, into sine inverse of x by a. So using that formula, x by 2 is what? T by 2 square root of 1 minus t squared plus a squared by 2 is what? 1 by 2 sine inverse of t minus what is integral of this one here? It's nothing but sine inverse of t plus a constant. So how do I write here? T squared sine inverse of t plus t by 2 into square root of 1 minus t squared. When I combine these both, 1 by 2 sine inverse of t minus sine inverse of t is what actually are? It's nothing but minus 1 by 2 sine inverse of t plus a constant. My answer must be in terms of x here, so I need to substitute the value of t. What is your t equal to here? Root x. So it is x into sine inverse of root x plus root x by 2 square root of 1 minus root x the whole squared will give you what? 1 minus x minus 1 by 2 into sine inverse of root x plus a constant. Okay. The 20th question, integral of square root of 1 minus root x by 1 plus root x dx. There are two ways of doing it actually here. One is by using the trigonometric substitution, that is you can put x is equal to cos t, root x is equal to cos t and then proceed. Otherwise, like how I did, multiplying and dividing by the conjugate of the denominator. So what is the conjugate of the denominator you get here? It's 1 minus root x by 1 minus root x. When I combine this, you will get it as square root of 1 minus root x the whole square divided by, this is nothing but a plus b into a minus b. So what is a plus b into a minus b? It's nothing but a squared minus b squared. So I can write it as 1 minus x dx, which is equal to root of 1 minus root x the whole square will be what? 1 minus root x divided by square root of 1 minus x. This is what you have here. So this is equal to integral of 1 by root of 1 minus x dx minus integral of root x by 1 minus root of 1 minus x dx. This is what you get here. I have just separated as two separate integrals, I1 minus I2. So we'll evaluate the first integrand here. Your I1 is equal to, what is your I1 equal to here? It is nothing but equal to integral of 1 minus x the whole power minus 1 by 2. When I take it to the numerator, for the sake of integration, I am just taking it here. Now when I integrate it by what formula? Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. This is the formula we have here. So when I integrate it, you will have it as 1 minus x the whole power 1 by 2 divided by minus 1 by 2. So when this goes here, you will be left with minus 2 into square root of 1 minus x. What is your I2 equal to? Your integral of root x divided by root of 1 minus x. What is your t equal to here? Here I'll have to use only the substitution method. I don't have any other option. So t is equal to root x. You will get t squared is equal to x. So what will I get? Your dx is equal to 2t dt. Your I2 is equal to integral of, it's t divided by root of 1 minus t squared, because your x is equal to t squared. And what is your dx equal to here? 2t dt. So here, in this case, of course the numerator, when I multiply, you will get it as t squared by root of 1 minus t squared. Already we have evaluated an integral like this. What is that I must get here? If I have minus 2 squared, I can add and subtract 1 and then integrate it easily here. So I am just taking multiplying and here minus sign here. Minus 2 integral of minus t squared by root of 1 minus t squared. Minus 2 into integral of add and subtract 1. 1 minus t squared plus 1 divided by square root of 1 minus t squared. So split it as two separate integrands here. Minus 2 integral of 1 minus t squared divided by root of 1 minus t squared. Minus into minus is what? Plus 2 integral of 1 by root of 1 minus t square dt. So when I rationalize this, what will happen here? It's minus 2 integral of the numerator, it becomes square root of 1 minus t square dt plus 2 into integral of 1 by root of 1 minus t square dt. So what's the formula we have here actually? Just now I mentioned the formula. What was it actually here? Integral of, what will I have here? It's nothing but square root of a squared minus x squared. What is it equal to? X by 2 into square root of a squared minus x squared plus a squared by 2 into sine inverse of x by a. This is the formula you have here. So using this formula, it's minus 2 into t by 2 x by 2 square root of a squared minus x squared 1 minus t squared plus a squared by 2. What is your a here? It's 1 by 2 into sine inverse of t plus, what will I get here? 2 into sine inverse of t plus a constant. Understood? Now multiply by the minus sign here. When minus 2 here, when you multiply, of course, what will happen actually here? You will, this one minus 2 into, again I'll have to substitute actually here the value of, what is it? I'll have to substitute the value of t. What is your t equal to here? T is equal to root x. This is what you have here. So when I multiply by the minus sign, what will I get here? It's minus, you will have 2 and 2 gets cancelled. Your t is root x, root of 1 minus x. Root by the x whole square will give you what? 1 minus x. When I multiply this, you will get it as minus sine inverse of root x, because 2 and 2 here also it gets cancelled, plus 2 into sine inverse of root x plus a constant. This is what you have here. Okay, so here this is what you get, minus x into root of 1 minus x plus, what will I get here? Sine inverse of root x plus a constant. I'll write the conclusion here. Your I is equal to I1 minus I2. What is your I1? Minus 2 into root of 1 minus x you get here. What is your I2 there? Minus I2 you get. So what will be minus I2 here? It's plus x into root of 1 minus x minus sine inverse of root x plus a constant. This is what you have here. This is your evaluation of this integral. Okay. So the 21st question, I is equal to integral of 2 plus sine 2x divided by 1 plus cos 2x into e power x. This is what you get here. So we'll just separate it as two separate integrands here. I is equal to 2 by 1 plus cos 2x plus sine 2x divided by 1 plus cos 2x into e power x dx. So here this is equal to integral of 2 divided by, what is your 1 plus cos 2x here? It's nothing but equal to 2 cos squared x plus, what is your sine 2x? It's nothing but 2 sin x cos x divided by 2 cos squared x into e power x dx. Okay. So here your 2 and 2 gets cancelled. It is integral of secant squared x, because 1 by cos is what? Secant squared x plus, here again if you see it gets cancelled, 2 and 2 also gets cancelled. Sine by cos is what? Tan x into e power x dx. So when I multiply and write it, it's integral of e power x into tan x dx plus integral of e power x into secant squared x dx. So when you integrate this, keeping it as it is, you can also use the formula which is mentioned in the book there. So what was a formula mentioned in the book actually here? If it is e power x into, it's f of x plus, what will I get here? F dash of x dx. What will I have here? It is equal to integral of which is equal to e power x into, what will I have here? It's nothing but f of x plus a constant. This is a formula you have here. So using that, okay, either you'd write it like that, otherwise I'll just integrate it by parts. Okay, because in my exercise I've just integrated it only by parts here. So here if you see, differentiation of tan x will give you secant squared x. So I'll just use a parts formula only for this. So which is your first one here? This is the first one and this is the second one. Tan x into integral of e power x dx minus integral of d by dx of tan x into integral of e power x dx plus e power x into secant squared x. So you will have it as e power x tan x minus integral of e power x into secant squared x plus integral of e power x into secant squared x dx. So here again it gets cancelled. So what's the answer you get here? It is equal to e power x tan x plus a constant. Okay. Now the 22nd question. So 22nd question is nothing but the partial fraction. I is equal to integral of x squared plus x plus 1 divided by x plus 1 the whole squared into x plus 2 dx you get. So here in this case, of course it's only by partial fraction method here. You have the whole squared into x plus 2. So what is the method you will opt here? It is equal to a by x plus 1 plus b by x plus 1 the whole square plus c by x plus 2. This is how you write here. So how is that I can write? X squared plus x plus 1 is equal to a into, taking the LCM, here you don't have x plus 1 and x plus 2. So a into x plus 1 into x plus 2 plus b into, here if you see it's nothing but x plus 2 plus c into x plus 1 the whole squared, because here if you see you don't have x plus 1 the whole square, c into x plus 1 the whole square. Now you put x is equal to minus 1. Okay, so when I put x is equal to minus 1, what will you get? 1 minus 1 plus 1 is equal to b into, I can put only here b into minus 1 plus 2 is what? 1. So here if you say it gets cancelled, what's the value of b equal to here? 1. The next one is what? Put x is equal to minus 2. When you put x is equal to minus 2, you will get it as minus 2 the whole square is what? 4 minus 2 plus 1 is equal to, here it becomes 0, here also it becomes 0. So c into minus 2 plus 1 the whole square is nothing but 1 squared. So 2 plus 1, that's nothing but 3. So here c is equal to 3. Okay, so here this is what you have here. Next is what? Put x is equal to 0. So when you put x is equal to 0, what will you have to find out? The other coefficient. It is 0 plus 0 plus 1. It's nothing but 1, which is equal to, here again 1 into 2, 0 plus 1. Okay, so you will get it as a into 2 plus b into 2 plus c. So what will I have? 1 is equal to 2a. What's the value of b here? 1. So 2 plus 3, you will get 2 plus 3 is 5. When I take it to the other side, 2a is equal to minus 4 and a is equal to minus 2. So you have found out the values of a, b and c. The next step is to substitute it in the integrand and then integrate it with respect to x. So here it is equal to, substituting the value of a, b and c, you have it as minus 2 divided by x plus 1 plus 1 by x plus 1 the whole square plus 3 by x plus 2 dx, which is equal to minus 2 into 1 by x plus 1 plus, when I take this to the numerator, you will have it as x plus 1 the whole power minus 2 plus 3 into integral of 1 by x plus 2 dx, which is equal to minus 2 into log of mod x plus 1 plus, here you will have it as x plus 1 the whole power minus 1 divided by minus 1 plus 3 into log of mod x plus 2 is what you have here, which is equal to minus 2 into log of mod x plus 1 plus into minus will be minus 1 by x plus 1 plus 3 into log of mod x plus 2 plus a constant. Yes, okay. Now here the 23rd question. It's integral of tan inverse of root of 1 minus x by 1 plus x dx. Again a slightly different one. If you see here substitution, by substitution only I can do it. That too by trigonometric substitution only it is possible here. Actually here I cannot do it by parts or anything like that. So here if you see, what is the substitution I can put? I cannot put sin t. If I put it as sin t, I'll get it as 1 minus sin t by 1 plus sin t. There if you see, I don't have any identity like that, 1 minus sin t. So the only possibility I have here is to put x is equal to cos t. So what is your dx equal to? Minus sin t into dt you get. I is equal to tan inverse of root of 1 minus cos t divided by 1 plus cos t into minus sin t dt, which is equal to tan inverse of 1 minus cos t is what? 2 sin square t by 2 divided by 2 cos square t by 2 into minus sin t. Of course it gets cancelled. You are left with integral of tan inverse of square root of tan square t by 2 into, what will I get here? Minus sin t. Okay, so this is equal to tan inverse of tan t by 2 into minus sin t. So what is tan inverse of tan t by 2? This gets cancelled. You are left only with t by 2 sin t dt. Okay. Now here this is equal to, I can take minus 1 by 2 outside. So of course I'll have to integrate it by parts only here. So when I integrate it by parts, which is the first one and which is the second one, what will I get here actually here? So this trigonometry, the algebraic is the first one and this is your second one. So it's the first one, okay, t into integration of the second one minus integral of differentiation of the first one, that's nothing but differentiation of t, into integration of the second one, that's nothing but sin t dt. Okay, so here we'll see how we'll integrate it with respect to t in this case, which is equal to minus 1 by 2 into minus t cos t, because integral of sin t is nothing but minus cos t minus integral of d by dt of t is nothing but 1 into integral of sin t will give me nothing but minus cos t dt, which is equal to minus 1 by 2. It's minus t cos t, minus into minus is nothing but plus sin t plus a constant. So it's minus 1 by 2 into minus t cos t. See here, actually the substitution I put was x is equal to cos t. Okay, that was the substitution I put. I need my answer in terms of x. But here if you see, I have cos sin t here. So I must bring that in terms of sin t. So I can write it as root of 1 minus cos squared t. So what will happen actually here? It's minus 1 by 2. Your t will be nothing but equal to cos inverse of x. So t can be written as cos inverse of x, and this can be written as nothing but x. So it is minus x cos inverse of x plus square root of 1 minus x squared plus a constant. So don't forget the last step here again to substitute it, okay, in terms of x. The 25th question, integral over pi by 2 to pi e power x into 1 minus sin x by 1 plus cos x dx. I is equal to integral over pi by 2 to pi e power x into, so what is that I'll have to do? Of course you'll have to do it by parts. Before doing it by parts, I'll have to simplify this. When I simplify it, what will I get? 1 minus, this can be written as what? 2 sin x by 2 cos x by 2 divided by 2 sin squared x by 2. Okay, so I'll just simplify it here. Pi by 2 to pi e power x into 1 by 2 sin squared x by 2 minus 2 sin x by 2 cos x by 2 divided by 2 sin squared x by 2. So here if you see, it gets cancelled. So you're left with 1 by 2 into cosecant squared x by 2. Here if you see, cos by sin will give you what? Cot x by 2. So you will have it as integral over pi by 2 to pi e power x into 1 by 2 cosecant squared x by 2 minus cot x by 2. So again if you see, it's of this form only, integral of x into, what did I tell you there? F of x plus f dash of x, because differentiation of cot x by 2 will give you what? Minus cosecant squared x by 2 into 1 by 2. Okay, so I'll just split it here. It's integral over pi by 2 to pi e power x by 2 into cosecant squared x by 2 minus integral of pi by 2 to pi e power x into cot x by 2. This is what you have here. So I'll have to use parts where actually are only for this one, because differentiation of cot only. So I'll just keep this as it is, minus, so which is your first one here actually, this is the first one and this is your second one. So it is cot x by 2 integral of e power x minus integral of d by dx of cot x by 2 into integral of e power x dx. So it's 1 by 2 pi by 2 to pi e power x into cosecant squared x by 2 minus, what is integral of e power x? It's nothing but e power x cot x by 2 over the limit, because here if you see, it's actually over the limit pi by 2 to pi. Don't forget to write the limit here, pi by 2 to pi. Minus into minus will give me plus here. Differentiation of cot x is what? Minus cosecant squared x by 2 into 1 by 2. Remember, okay. Integral of e power x is what? E power x itself dx. Got it? So here, this is equal to 1 by 2 integral over pi by 2 to pi e power x into cosecant squared x by 2 you get here, minus, apply the upper limit here, e power pi into cot pi by 2 minus e power pi by 2 into cot pi by 4. Now here if you see, you have plus into minus is minus, you have this 1 by 2 here. When I take it, it's minus 1 by 2 integral over pi by 2 to pi e power x into cosecant squared x by 2 dx. So what will happen here? These both will get cancelled. Now here if you see, cot pi by 2, what is cot pi by 2? That's nothing but equal to 0. So it's minus 0. E power pi by 2, what is cot pi by 4? It's nothing but equal to 1. So what's the answer you get here? It is equal to e power pi by 2. Okay. Here the 26th question, evaluate integral over 0 to pi by 4 sin x cos x divided by cos power 4x plus sin power 4x dx. Okay. So here again it's a definite integral here. So here directly I cannot use substitution, because here you have got sin x into cos x, here you have got cos power 4x into sin x, cos power 4x plus sin power 4x. So here we'll see how we can do. I is equal to integral over 0 to pi by 4 sin x cos x by cos squared x the whole square plus sin power 4x, because I'm going to write this also in terms of sin. So how do I write it here? 1 minus sin squared x the whole square plus sin power 4x dx. Now I can use the substitution method. So what's the substitution I put here? T is equal to sin squared x. Your dt by dx is equal to 2 sin x cos x. What's your dx equal to here? dt divided by 2 sin x cos x you get. So similarly, since it's a definite integral, I have to be a little careful with the limit. So we'll substitute, we'll change the limit also here. When x is equal to 0, you will get t is equal to sine 0, that's nothing but equal to 0. When x is equal to pi by 4, that's the upper limit, you will get t is equal to sine squared pi by 4. What is sine pi by 4? It's nothing but 1 by root 2 the whole squared you will get. That's nothing but equal to 1 by 2. This is what you have here. Okay. So I is equal to integral over 0 to 1 by 2 sin x cos x divided by 1 minus t the whole square plus t squared you get, because you have it as sine power 4x, so it will be sine square the whole into dt divided by 2 sin x cos x. Of course it gets cancelled, which is equal to 1 by 2 integral over 0 to 1 by 2. It is dt divided by expanded 1 minus 2t plus t squared is what you get here. So it's 1 by 2 integral over 0 to 1 by 2 dt divided by t squared plus t squared is what? 2t squared minus 2t plus 1. Okay. So can you factorize this? No. So what is the method I'll have to use here? I'll have to use a complete form. So I'll just take this 1 by 2 integral over 0 to 1 by 2. It is dt divided by, taking this 2 outside, you will have it as t squared minus t plus 1 by 2. Okay. So here it's equal to 1 by 4 integral over 0 to 1 by 2. What was the equation you got? T squared minus t minus 1 by 2. Sorry, plus 1 by 2. This was the thing. So what's the coefficient of t here? It's nothing but 1. So when I divide it by 2, you will have it as 1 by 2. That I'll have to add and subtract it. That's squaring and adding. Okay, so here I'll have to square and add and subtract it also. So it's dt divided by t squared minus t plus 1 by 2 the whole squared minus 1 by 2 the whole squared plus 1 by 2. What is this actually here? It's nothing but a minus b the whole squared. So what is the next step I write here? 1 by 4 integral over 0 to 1 by 2 dt divided by t minus 1 by 2 the whole squared. You will have it as minus 1 by 4 plus 1 by 2. What is minus 1 by 4 plus 1 by 2? That's nothing but equal to 1 by 4 plus 1 by 4. So how do I write? 1 by 4 integral over 0 to 1 by 2 dt divided by t minus 1 by 2 the whole square plus 1 by 4. So what's the formula I'm going to use here? Integral of dx divided by x square plus a square. What's the formula you get here? It's 1 by a into tan inverse of x by a. This is the formula you get. So it's 1 by 4. 1 by a is what? It's nothing but 1 by 2 into tan inverse of t minus 1 by 2 divided by a. What's the value of a? It's 1 by 2 over the interval 0 to 1 by 2. Now here if you see, of course it gets cancelled. You are left with 1 by 2. Substitute the upper limit. Tan inverse of 1 by 2 minus 1 by 2 will give you what? 0. Minus tan inverse of 0 minus 1 by 2 is what? Minus 1 by 2 minus by 1 by 2. So here you will get it as tan inverse of minus 1. What is tan inverse of minus 1? It's nothing but equal to minus pi by 4. Okay. So here tan inverse of 0 is nothing but 0. So you will have it as 1 by 2 into minus of minus pi by 4 is what? Plus pi by 4. What's the answer you get here? It's equal to pi by 8. Okay. Now here the 29th question. It's integral over 0 to 1 by root of 1 plus x minus root x dx. Whenever you have something like this, somehow or the other, try to eliminate the square root in the denominator. So that is possible only by multiplying and dividing by the conjugate. Okay. So that's what I have done here. I is equal to integral over 0 to 1 divided by root of 1 plus x minus root x into root of 1 plus x plus root x divided by root of 1 minus 1 plus x minus root x. Okay, so here plus root x you have here, multiplying and dividing by the conjugate. So you have it as a minus b into a plus b. So you have it as root integral over 0 to 1 root of 1 plus x plus root x divided by a squared. You will have it as root of 1 plus x the whole squared. What is root of 1 plus x the whole squared? It's nothing but 1 plus x minus root x the whole squared. What is root x the whole squared? It's nothing but x. So your x and minus x gets cancelled. You are left with integral over 0 to 1 root of 1 plus x plus root x. So I'll have to integrate this one. When you integrate it, what will I have? 1 plus x the whole power 3 by 2 divided by 3 by 2 plus x power 3 by 2 divided by 3 by 2. So here this 3 by 2, when I take the inverse of it, it's nothing but 2 by 3 into applying the upper limit. 1 plus 1 is what? 2 power 3 by 2 plus 1 power 3 by 2 minus the lower limit. So minus, what will I get? 1 plus 0 the whole power 3 by 2. That's nothing but 1, 0. This is what you get here. So this gets cancelled. This 2 power 3 by 2 can be written as 2 into root 2. So what's the answer you get here? 4 root 2 divided by 3. The 32nd question, integral over 0 to pi x tan x divided by secant x plus tan x dx. So here in this case, if you see, I'll have to use the definite integral property. So I'll just write it as I equal to integral over 0 to pi x tan x divided by secant x plus tan x dx. See if you can do it by substitution method, not possible here. So I'm going to make use of this property here. Integral over 0 to a f of x dx is equal to integral over 0 to a f of a minus x dx. So your I is equal to integral over 0 to pi. It becomes pi minus x tan of pi minus x divided by secant of pi minus x plus tan of pi minus x dx. So your I is equal to integral over 0 to pi minus x into tan of pi minus x is nothing but tan x divided by secant of pi minus x. What is it? It is secant x plus tan x dx. Now here you will write this as 1 and 2, add 1 and 2. That's here the question, and this one here. When you add it, what is that you will get here? Actually here it's 2I equal to integral over 0 to pi. It's x tan x divided by secant x plus tan x plus pi minus x into tan x divided by secant x plus tan x dx, which is equal to integral over 0 to pi. When you add it, it's x tan x plus pi into tan x minus x tan x divided by secant x plus tan x. What happens here? It gets cancelled. You're left with integral over 0 to pi. It's nothing but pi tan x divided by secant x plus tan x dx. Again, there's a problem with integration here. So how will I integrate it here? We'll see. We can simplify it and keep. So integral over 0 to pi, I can write it as pi into sine by cos divided by 1 by cos plus sine by cos here. So here in this case, this cos, everything it gets cancelled. You're left with pi into integral over 0 to pi sin x divided by 1 plus sin x dx. Now how will I integrate this one here? Yes, I'll have to multiply and divide by the conjugate of the denominator, because here both I have it as sines. I cannot make use of the substitution method also. So when I multiply and divide by the conjugate of the denominator, you will have it as pi into integral over 0 to pi sin x into 1 minus sin x divided by 1 plus sin x into 1 minus sin x, which is equal to pi into integral over 0 to pi sin x minus sin squared x divided by a plus b into a minus b. You will have it as 1 minus sin squared x, which is equal to pi into integral over 0 to pi. It's sin x minus sin squared x divided by cos squared x dx, because what is 1 minus sin squared x? It's nothing but equal to cos squared x. Okay. So you have it as pi into integral over 0 to pi sin x by cos squared x minus sin squared by cos squared x dx, which is equal to pi into what will you get here? Integral over 0 to pi tan x into secant x minus tan squared x dx, which is equal to pi into integral over 0 to pi. Here to integrate this one, I will write it as secant squared x minus 1, because I don't know what is the integral of tan squared x there. Now we'll integrate it. Pi into integral of secant x tan x is what? Secant x minus what is the integral of secant squared x? It's nothing but tan x. Now here minus into minus will give me what? Plus here. So plus x. Okay, integral of a constant over the limit 0 to pi. So it's pi into secant pi. What is secant pi? Minus 1 minus tan pi, it is 0 plus pi minus the lower limit. Secant 0 will give you what? 1 minus tan 0 will give you what? 0 plus 0. Okay. So it's 2I equal to pi into minus 1 will give me what? Minus 2. So it's pi minus 2. Pi into pi minus 2. What's your I equal to here? Pi by 2 into pi minus 2. Okay. Now the 33rd question, it's an important one here. Under the exercise for definite integral, we would have seen only integration of just one absolute function here, but here it's not like that. You have sum of 3 absolute functions. Integral over 1 to 4 mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3. So what all you get here actually are for x greater than 1, x less than 1, you will get x greater than 2 and x less than 2 and x greater than 3 and x less than 3. This is how you get. So how is that I can split my interval here actually here? 1 to 2, next is what? 2 to 3, and the next one is what? 3 to 4. Okay, so here this is how you have here, because it's from 1 to 4. So first I'll just split and write it as integral over 1 to 2 mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 dx. plus integral over 2 to 3 mod of x minus 2 plus mod of x minus 2 plus mod of x minus 3 dx plus integral over 3 to 4 mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 dx. Okay. So the first one is what actually here you have it as integral over 1 to 2. You had it as mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3. This is what you get. So if it is from 1 to 2, what will I get here actually? Here it's nothing but x is said to be greater than 1. Okay, but x is said to be less than 2 as well as it is said to be less than 3. So if it is less than, if it's greater than 1, your mod of x minus 1 will be nothing but x minus 1 itself. If it is less than 2, what will I get? Mod of x minus 2 will be equal to minus of x minus 2. You remember the absolute value function mod x is equal to minus x when x is said to be less than 0. So minus of x minus 2. Here again mod of x minus 3 can be written as minus of x minus 3 dx. Plus what's the next one? Integral over 2 to 3. So what is integral over 2 to 3 means? It is actually x greater than 2, x less than 3. So naturally it will be x greater than 1 also, because it is also greater than 1. So mod of x minus 1 can be written as x minus 1. Mod of x minus 2 can be written as x minus 2. Only your mod of x minus 3 will be written as minus of x minus 3 dx. Okay. Plus the next one 3 to 4. So 3 to 4 is what? It is just x again. X is greater than 1, x is greater than 2 and x is greater than 3. So everything will be positive. Mod of x minus 1 I can write it as x minus 1. Mod of x minus 2 can be written as x minus 2. Mod of x minus 3 can be written as plus x minus 3. You understood here? So it's only basically this absolute value definition here I am using. Now here you see your x and minus x gets cancelled. You're left with minus x. Minus 1 plus 2 will give you what actually here? It's nothing but 1. Okay, 1 plus 3 will give me nothing but 4. Minus x plus 4 dx plus integral over 2 to 3. Here again your x and minus x gets cancelled here. You're left with what actually here? X minus 1 minus 2 is what? Minus 3. Minus of minus is plus 3 will give me what? 0. So you will have only x dx plus x plus x is what? 3x. Minus 1 minus 2 minus 3 will give me what? Minus 6. So I have written it as integral over 1 to 2 minus x dx, minus x plus 4 dx plus integral over 2 to 3 x dx plus integral over 3 to 4 3x minus 6 dx. Now we integrate it. Minus x squared by 2 plus 4x over the limit 1 to 2 plus x squared by 2 over the limit 2 to 3 plus 3x squared by 2 minus 6x over the limit 3 to 4. Substituting the limit, upper limit it's minus 4 by 2 plus 4 into 2 is 8 minus the lower limit, minus of minus it's plus 1 by 2 minus 4 plus 9 by 2 minus 4 by 2 plus here again 3 into 4 squared is what? 16. So 16 into 3 is what? 48 by 2 minus 6 into 4 is 24 minus the lower limit will give me what? Minus 3 into 3 squared is what? Minus 27 by 2 minus the lower limit. So you already have a minus sign here. Minus of minus it's plus 6 into 3, that's nothing but 18. Now here minus 4 plus 1 is what? 3. 3 plus minus 3. Minus 3 plus 9 is what? 6. 6 minus 4 is what? 2. 2 plus 48 is what? 50. 50 minus 27 is nothing but 23 by 2. Okay, all the fractions I have just added or subtracted whatever it is. The remaining 8 minus 4 it's 4. Here again the next one what will you get? 4 minus what will you have here? It is 24 is nothing but minus 20. Minus 20 plus 18 will give me what? Minus 2. So now when I take the LCM what will I get? 23 minus 4 by 2, that's nothing but equal to 19 by 2. Yes. Now the next one, integral over 1 to 3 1 by x squared into x plus 1 dx is equal to 2 by 3 plus log of 2 by 3. This is what you'll have to do here. So when I integrate it, how will I integrate it here? By partial fractions, because you have it as x squared into x plus 1. First we'll split it by partial fractions, then integrate it and then substitute the limit there. So 1 by x squared into x plus 1 is equal to a by x plus b by x squared plus c by x plus 1. So 1 is equal to a into what will I get? X into x plus 1 plus b into x plus 1 plus c into x squared. When you take the LCM here, what is that you don't have? 1x you don't have, 1x plus 1. Here what is that you don't have? Only x plus 1. Here what is that you don't have? X squared. So what are the roots you get? X is equal to 0. You will get 1 is equal to, this becomes 0. So you will have b into 0 plus 1 is nothing but b. This also becomes 0. So b is equal to 1. Next is x is equal to minus 1. What will I get? This becomes 0. Here also it will become 0. Plus c into minus 1 the whole square is nothing but c equal to 1. So equating the coefficient of x squared. What will I have? 0 is equal to ax into x. It's nothing but a. Here again you will have it as plus c. So you get 0 is equal to 1 plus c. So what's the value of a you get here? Actually here your a is equal to minus 1. You understood? So here your c is equal to 1 I substitute. So you will get a is equal to minus 1. Now substitute the limit in this case actually here. Integral over 1 to 3. It's minus 1 by x you have here. Plus 1 by x squared plus 1 by x plus 1 dx. Okay. Now I'll have to integrate this one. So you have it as integral over 1 to 3 minus 1 by x dx plus 1 integral over 1 to 3, that 1 by x squared can be written as x power minus 2 plus integral over 1 to 3 1 by x plus 1 dx. So here this is equal to minus log x over the limit 1 to 3. Here again it is plus x power minus 1 divided by minus 1 over the limit 1 to 3 plus log of mod x plus 1 over the limit 1 to 3. Now substitute the limit. Minus log 3, minus of minus is nothing but plus log 1 minus, here again you will have it as minus 1 by x. When I substitute the limit, you will have it as minus 1 by 3 minus the lower limit. Minus of minus is nothing but plus 1 you will have here, plus log of 3 plus 1 is what? Log 4 minus what will I get here? It's nothing but log 2. Got it? Okay. Now here this one, here if you see you have it as log 4, okay, this here minus, here you have minus, so that comes in the denominator. What's the formula here? Log of m by n. What is log of m by n? Equal to log m minus log n. This is the formula you have here. So I can write it as log of 4 by 3 into 1 by 2. Log 1 is nothing but 0 minus 1 by 3 plus 1 is nothing but 2 by 3. So what will I have? Of course it gets cancelled. So you're left with log of 2 by 3 plus what will I have here? It's nothing but 2 by 3.